Okay, so in chapter 17, we're going to be looking at application of integration. Okay, so one of the many application of integration is to figure out the area under the graph itself. Okay, why we want to do that? Because later on we're going to explore on kinematics. Okay, and kinematics we're talking about your speed and all that. Okay, that kind of situation. So we start off with looking at areas under a graph. Okay. We're looking at a definite integral. Okay, earlier on we were looking at indefinite integral. What is the difference between indefinite and definite? Okay, as the word suggests, indefinite means that there is nothing that is certain. Why is there the uncertainty in indefinite integrals? It is because of this existence of a plus c. Okay, so plus c itself, depending on whatever value of c we have, okay, there is that uncertainty, there is that indefinity, if there is such a word for it. Okay, whereas for definite integral, there is that certainty, right, which explains why we call it definite integral. So how do we find a definite integral? So for example, okay, taking an example from try 1. Okay, in a definite integral there are boundaries. We have a lower boundary and upper boundary. So your a and b over here are numbers that may be given or numbers that you may need to find. Okay, so upper boundary and lower boundary. Okay, typically your value of a is smaller than your value of b. Okay, so it is usually arranged in the increasing order. Usually lah. Okay. So in part A itself, let's say we're given this example. We're trying to integrate from -1 to 2. So from -1 to 2, that's how we read it. Okay, integrating this function. So we will integrate as per normal. Okay, integrating your 5 will give us 5x. Integrating x will give us x squared over 2. And then integrating minus 3x squared will give us minus 3x cubed over 3. Okay? In our indefinite, we always have to do a plus c. But since we're given this boundary itself, we don't need to put a plus c. However, we will put our square brackets and we put in the boundaries itself. Okay? So this is the integration. Must be square brackets, cannot be round brackets. It's just conventions that we use in mathematics. Okay, but that is not all. Alright? What we need to next do is to find out the value itself. Okay, because we know that this definite integral is supposedly to represent an area. Area has a value itself. So how do I find the area? I will take the value 2, substitute inside this. Then minus away, taking -1, substitute inside here. Okay, so I will have 5, 2 minus 2 squared over 2 minus 3 cubed over 3. Then minus away. Is it? Oh, sorry, plus. Okay, thank you. Then minus away, substituting -1 in. Okay. So this is when x equals to 2. Lower bound and upper bound. Sorry, maybe I think it's the word is bound, not boundary. Then lower bound and upper bound. key in your calculator for this entire thing. And you will get 7.5. If you want to do it part by part, that's also possible. You should get 4 minus away negative 7 also. Okay, so we get 7.5. Since this question did not give you a context, we're not exactly finding area yet. We're just finding out how to do definite integrals. So no need for any units. Okay, unless there's a context given. Okay, they specifically ask you to find the area under a curve. Then when we integrate, we need to put in the unit square. Okay, but we have not come to that stage. Integrate t minus 1 over t square with respect to t from 1 to 4. Okay, what should we do first? Calling out a name. Wait, what do you think we should do first? Expand. Okay, can I just do my power rule in this case? Can you all please look at your formula booklet? Okay, hope you notice that we cannot and add the power and then after that divide and all that. Okay, because the inside it is not linear. It is not of the form ax plus b. So we must expand. So when is right? Okay, so t squared minus away t times 1 over t plus 1 over t squared. Okay, then we simplify it before integrating. Okay, so integrating t square minus 2 plus 1 over t square, what will we get? Diana, what do you think? T cubed over 3 minus 2t t to the power of negative 1 over negative 1. Okay, and then we have our boundaries. Okay, so take note that this is 1 over t square, which is t to the power of negative 2. Okay, so integrating your t to the power of negative 2 will give us t to the power of negative 1 divided by negative 1. Okay, so not your logarithms. Then you may want to tidy this up. 1/3 t cubed minus 2t minus 1 over t. Okay, you need not show the working of the substitution like what I did here. You can directly press into your calculator, just that you got to be very careful about how you place the brackets. Okay, so you need to have brackets around the first set and brackets around the second set before you subtract. Otherwise, your operations may be messed up. Okay, so the reason why I wrote this is for our understanding, okay, knowing what to key in your calculator. Right? So if you are the very careless type, then I would suggest that write it out first before you key in your calculator. Okay, so for the second set, we know that t is equals to 1, so all the t's actually become 1. So I don't bother to write down. Okay, then key into your calculator, and we will get 15.75 or 15 3/4. this on your own. Try to just do part A is good enough already. Okay, can you work on it now? So, part C, you will get x3 over 2 over 3 over 2 minus x squared over 4. Okay, that's for try 1 part C. Okay, for part D itself, you need to separate out into 2 separate fractions first, which I saw that most of you were able to get that done yesterday. Okay, then after that you need to simplify it. Just want us to be very careful. Okay, when it comes to integration, I think generally when I walked around, I saw most of you are okay with this. Okay, but do be very careful that when you substitute in the x equals to 0, right? Okay, cosine 0 is not 0. So please do a check with your calculator. Okay, unless you can remember your cosine graph itself looks like this. At x equals to 0, okay, it is actually a maximum, which explains why it is a 1. So 2 times 1 is a 2. Okay, so may not want to rely on your mental calculations, okay, so often all the time, right? So it's the same idea when you do your exponential x to e to the power x equals, where x equals to 0. Okay. Then for try 3. Okay, for try 3 part E, when we integrate, we should get e to the power of 3x over 3. Okay, since integrating an exponential function will maintain it to be the same, we just have to divide by the coefficient of x. Okay, so we practice leaving things exact as well, because there are times whereby the question will want you to leave your answers to exact. Okay, so therefore, substituting x equals to 3, we get e to the power of 9. And then substituting x to be 0, we get e to the power of 0, which is 1. I can factorize out 1/3, so it explains why our answer will be 1/3 times e to the power of 9 minus 1. Okay? Followed by part B. Okay, for part B itself, right, not as straightforward when it comes to the integration because of the denominator, because the function appears in the denominator. However, we can resolve that problem, okay, by recognizing that your denominator Okay, the e function itself is the same as e to the power of negative x plus 1, where I factorize out the negative sign. Okay, then because of the negative power, we can bring the e function up into the numerator. So we have 2e to the power of x plus 1 instead over 3. Okay, so we can now observe our function here as though it is 2/3 e to the power x plus 1. Okay, so the 2/3 constant could be brought out, which means that you can ignore that. Otherwise, we can just maintain it inside, focus on the e to the power x plus 1, which maintains to the e to the power x plus 1. Since there is no coefficient of x, which means that it is a 1, we're just dividing by 1. Okay. By the way, I noticed that for some of you, when you, let's say, resolve the round brackets, like this case over here, right? Okay, you change your square brackets into round brackets. Just want to inform or remind, okay, that this square brackets is a matter of notation. It is not meant to change from square to round. Okay, so just keep it square when you have your boundary values over here. Okay, then we substitute in the values, and we will have 2/3 e ln 3 plus 1 minus away 2/3 e to the power of 1. Okay. And then if you want to leave it in exact, shall I write it? Right here enough. We will have 2/3 e ln 3 times e minus away 2/3 e. E to the power of ln 3 is actually 3. You can press into your calculator to verify that. So it's 2/3 times 3. That is why we get a 2. E minus 2/3 e. It can be simplified like your algebra. So 2 whole minus 2/3, and we will get 4 over 3. Okay. Usually for coefficients, we don't write as mixed numbers. So we don't leave it as 1 and 1/3. Okay. Any questions for part B or try 3, A and B? Questions? Yeah. Then I'll just continue to try 3 part C first. For part C, we need to separate out into 2 separate fractions since the denominator is a single function, x. Okay. And then we simplify it to get 2 minus 3 over x. Okay. The x is actually a power of 1. So that means that when we integrate, we need to integrate into a ln. So we get 2x minus 3 ln x. Okay, with the boundaries 2 and 4. To leave our answer in exact, if the question were to ask you to leave it exact, okay, we substitute in the values. So that will be 8 minus away 3 ln 4 minus away 4 minus 3 ln 4. Okay. So just really practicing putting values into exact first. But then we still need to simplify it. So we will get 8 minus 3 ln 4 minus 4 plus 3 ln 2. 8 minus 4 is 4. For this minus 3 ln 4, we can see that 4 is actually 2 square. Okay, and by our logarithm rules, our 2 can be brought down such that 3 times 2 gives us 6. Okay, and that will help us to simplify minus 6 ln 2 with plus 3 ln 2 into 4 minus 3 ln 2. Okay. Questions? Yeah? Shall we move on? Okay, so we have done all the integration part, okay, for definite integrals. So let's take a look at how definite integrals will look like if we have to apply the concept of differentiating first followed by integrating. So looking at try 4, okay, in part I we want to differentiate 4x over square root 1 minus x with respect to x. Okay, it's really very beneficial if you know how to apply your quotient rule, because I know that some of you still very contented with doing product rule. Alright, while that may work, okay, sometimes it is more challenging using product rule and then having to simplify. Okay, so I will stick with using our quotient rule. So keeping the bottom, differentiate the top, minus away, keep the top, differentiate the bottom, and then bottom square. Okay, very often I notice in some of your homework, okay, your negative x tends to be forgotten in terms of differentiating when applying a chain rule. Okay, so this entire part is the differentiation of square root 1 minus x. Okay, so we brought the power down, power minus 1, not forgetting the inside, still need to have this negative 1. Okay, so upon simplification, we will get plus 2x over square root 1 minus x over 1 minus x. Okay, we simplify it into a single fraction, so we need our denominators to be the same at the numerator portion, so we will have to multiply by square root 1 minus x, which leaves us with a full 1 minus x plus 2x, and then our square root 1 minus x can be brought down. Okay. Then we get 4 minus 4x plus 2x over 1 minus x to the power of 3 over. And simplify further, you will have 4 minus away 2x over 1 minus x to the power of 3. Okay. So if you don't know how to do your quotient rule, you will definitely find it maybe slightly more challenging in terms of simplifying to arrive at a single fraction. Okay, and why is a single fraction necessary in this case? Because in part 2, we are asked to integrate or evaluate negative 8 to negative 3, 2x over square root 1 minus x to the power of 3. Okay. So, if you had not arrived at this answer, you will definitely find it a struggle in terms of how hence would actually apply, okay, for part 2. Okay? Because only when you have the single fraction in part I, then you will notice that part 2's expression can be found over here. Okay? Right? So we proceed with integrating. Right? So I'm not going to just start from here and then continue. Okay? We always, whenever we get asked to differentiate and then integrate, right? Okay, I always like to just take this answer, integrate it, and go back to this first. So I formed that one single statement. Okay, 4 minus 2x over 1 minus x to the power 3 over 2 equals to your 4x over square root 1 minus x. Okay, so I'd like to form this statement first. Now, in this statement that I've just written, there are things that are missing, which is the plus c. Okay, so it really depends on yourself whether you want to keep it to an indefinite integral first. That means you put the plus c over here, and then you do all the shifting. Okay, before you actually arrive back at this to find out what is a definite integral. Otherwise, you can remove the plus c and immediately start with the definite integral of negative 8 to negative 3. Okay? Right? But even if you write like that, okay, this statement itself also is not making much sense until you put your square brackets, negative 3, negative 8 like that. So it's a matter of presentation and consistency. Okay? So you may find it a hassle to have all these brackets going around. The fact that it's already a fraction can be very messy. So personally, what I will choose is just work with an indefinite integral first. Okay, until I can make this as the subject, then I go back to definite integral. Okay, so I'll just work with this first. So in this part, we have already identified that the 2x over 1 minus x power 3 over 2 is what we need in order to answer the question. So I'm going to separate this into two separate fractions. 4 over 1 minus x to the power 3 over 2 minus 2x over 1 minus x to the power 3 over 2. Okay? And my goal was to have this as the subject. So I'm just going to keep that, okay, whereby I'm integrating 2x over 1 minus x power 3 over 2 dx, which is only possible for it to be positive when this is kept here, this one shift over, the rest move to the left. So a little bit of manipulation over there. Okay, so this one is negative, right? So it's not about this one shift over, but more of things shifting around. You all see that? Okay, so I'm going to write it as integrating 4 over 1 minus x power 3 over 2 dx minus 4x over square root of minus x, then minus c. Okay, so this is now the subject already. Right? Then at this stage, if you want to already put in the definite integrals, okay, that means your negative 8 to negative 3, you need to apply to this as well. Okay, but what I would prefer to do is to just integrate this one first before I do anything, okay, related to that. So for this part, okay, when we integrate it, because this is a power of 3 over 2, we do our usual, okay, meaning to say we see it as negative 3 over 2. So we will get 4 and then power plus 1, so that will be negative half, divide by negative half, and not forgetting coefficient of x, that's negative 1. Okay? Then minus 4x over square root 1 minus x, and then I'll just put all the constants into one constant itself, which is plus 2. Okay? Any questions at this stage? Right, so we simplify this part. I'll erase this here. Okay, so simplifying it, we will get 8 over square root 1 minus x minus 4x over square root 1 minus x plus d. Step. Okay? Then you can put this together since the denominator is the same. Okay, so we get 8 minus 4x over square root 1 minus x. Okay, so I focus solely on the integration first. Okay, then now going back to answering the question. Okay, where we put in the boundaries. Okay, so once this is in place, what it actually means is that we can drop the plus d already, put square brackets around our integral that we managed to get already. Okay, then after that put in the values. Right? So we focus on one task at a time rather than to jumble everything up. Okay, so when you jumble everything up, there's a tendency for presentation problems, okay, whereby things can be mathematically illogical as you present, right, or you get confused yourself. Okay, then now just put in the numbers, and we will be able to get, hang on, 20 over 4 minus 3. Okay, so sub in your negative 3 and then sub in the negative 8. So upon substituting negative 3, numerator is 20, denominator will be square root 4, which is 2. And then sub in negative 8, numerator will be 40. Okay, and then denominator will become square root 9, which is 3. Okay, and then your final answer will be negative 10 over 3. Okay. Any questions? solutions? Yes, Regine.
The textbook says 7/3.
Textbook says what?
7/3.
7/3. If I do another method, I also get negative 10/3 though. Right, I made a mistake anywhere.
Oh, see.
Yeah, I made a mistake anywhere. Anybody spot anything? My differentiation part. Cannot be what? Yeah, I made a differentiation error just now. 4 minus 2x, right? Please differentiate this top, differentiate bottom. Then is 2x plus 2x. Correct? 4 minus 4x minus 2x. Correct one? You know what? I brought my laptop. We check the answer key. Okay. Sometimes the answer key in green is wrong. But you all see any errors? You all check then I check the answer key. Takes a while. This is chapter 17, triangle. But the differentiation that I did, 4 minus 2x, my differentiation is correct one, right? Follows the answer key. It's just the area. In the full solution, it says negative 10/3. Yeah, so it's their building problem. Okay.
Okay, so answer fine? Yeah.
So answer should be negative 10/3.
Then go.
Okay. Let me just write this here. Textbook answer key wrong. Okay. Anything else? Yeah. Then let's move on. Okay, so chapter 17.1. Alright, that's cleared already. Okay, so for homework, exercise 17.1. Let me cut it down. Would like you to do question 8, 9, 10, 12 and 13. Due on Friday, okay, that will be 16, 17, 18, 19. Okay, due on Friday. Right?